Everyone, welcome once again to this online session. So this is once again physics class for standard 9, and we were doing this chapter, gravitation. So I have taught almost all the topics that are there from this chapter, leaving those portions which are omitted, like thrust and pressure, buoyancy, Archimedes principle. These things are omitted, leaving that rest of the things were taught in the earlier sessions. So today I'll take a quick revision of all the topics that we had done in the earlier sessions, and then we'll proceed with numericals. Okay. So we'll be revising the topics that we had learnt in the previous sessions, like what is gravitation, your universal law of gravitation, importance of universal law of gravitation, what is free fall, acceleration due to gravity, mass and weight. So hope you are all able to recollect after I had read the topics that we had done. No issues, no worries, we'll do once again. It's a kind of revision, so pay attention now. So let's begin with gravitation. See, you all know that whenever you throw an object, it comes downwards, that is towards the earth. Why does it happen? Because the earth is exerting a force on the object and it tries to pull it towards itself. This force, which is exerted by the earth, is what is called as your gravitational force, or you can call it as gravity, right? So you must have observed in your day-to-day life a ripened fruit or a leaf, a withered leaf falling off from a tree. Why do they fall? They don't move in any other direction. You must not have seen them moving towards the sky or moving in any other direction. A ripened fruit, a withered leaf, they all come towards the earth. Why? That is all due to gravity. So what is gravity? Gravity is the force with which earth attracts the object towards itself. See, I have told you before also, when the earth is exerting a force on the objects above it, the object is also exerting a force. Since our mass is negligible when compared to the mass of the earth, or you can say the mass of earth is huge, that's why the objects are being pulled towards the earth. That is what you will be doing in your universal law of gravitation. So gravity can be defined as the force with which earth attracts the object towards itself, or in other words, you can assume the earth to be behaving like a magnet and all the objects above the earth's surface as objects made of iron, because magnet has the capacity to attract iron objects. But this earth is exerting a force on the objects to pull it towards itself. At the same time, the object is also exerting a force, but that force is not experienced, or it's not affecting the earth because the mass of the earth is huge. Our mass goes negligible there. Okay, now what is universal law of gravitation? You remember we had done a derivation for this. It states that every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This is what I told you just now. Every object in the universe attracts every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So when earth is exerting a force on us, we also exert a force on the earth. But that force is not playing its role because we are not able to pull the earth towards us because of its huge mass. So how much amount of force is being exerted? The amount of force that is exerted is directly proportional to the product of the masses. As the mass increases, force applied will also increase, and inversely proportional to the square of the distance between them. That means distance and the force applied are inversely proportional to each other. Means what? Distance is less, force of attraction is more. That is square of the distance. Inversely proportional to the square of the distance between them. Clear to you? Understood? So, once again I'll tell you how to derive the value of this capital G, that is gravitational constant. We had done earlier. Once again I'm doing a quick revision of the same derivation. Please watch it carefully. Okay. Consider two objects with masses capital M and small m. Suppose if we consider two objects as A and B, let the mass of object be capital M and the mass of the other object be small m. So according to your universal law of gravitation, F is proportional to product of their masses, that is mass of the object A and the mass of the object B, and inversely proportional to the square of the distance between them. Let us assume that these two objects are located at a distance d away from each other. So F is proportional, that is F is inversely proportional to square of the distance between them. When we combine these two equations, we get F is proportional to mm upon d square. So in order to remove the proportionality symbol, you always have to introduce a constant. Let the constant that we introduce there be equal to G. So F is equal to G mm upon d square, where this G is what is known as your universal gravitational constant. Or from this, see, we have learnt F is equal to G mm upon d square. If we want G, it is fd square upon capital M into small m. This derivation we have learnt in the previous class when I had started with the lesson. I am just giving a revision. I am repeating that once again to you. And this value of this gravitational constant G is 6.67 into 10 raised to minus 11 Newton meter square kg raised to minus 2. Hope it's clear. Now let's move on to the next slide. See, this also we have seen. What is the importance of universal law of gravitation? It is a force that binds us to the earth. If gravity does not exist, then we will not be bound to the surface of the earth. We will be floating in air. Moon has no gravity. That's why people going there are not able to keep their foot on the floor, I mean the surface over there. And there is no gravity, there is no binding force. So this gravity or gravitation, or you can say this universal law of gravitation is important because it is a force that binds us to the earth. The motion of the moon around the earth is also possible only because of this. The motion of planets around the sun, for this also this universal law of gravitation is important. And the tides due to moon and the sun. This is given in your textbook. Please have a look at it. Now, next we have learnt about free fall. I've taught you. See, you must have observed leaves shedding down from a tree, ripened fruit falling down from a tree. Here, these objects which are ripened are falling down from a tree on its own. It's only because of Earth's gravity. No other external force is applied on it. So, when the Earth attracts object towards itself due to gravitational force, we say the objects are showing free fall. You remember when I did this session, means when I had started with this lesson, when I taught you this concept, I had shown you an animation, a mango falling down from a tree, a leaf, withered leaf falling down from a tree and all. So what is free fall? Earth attracts objects towards it due to gravitational force. When objects fall towards the earth under the influence of this force, that is this gravitational force, we say the objects are in free fall. Okay, next, you remember we had done the derivation for acceleration due to gravity, small g, right? So what is acceleration due to gravity? Acceleration due to gravity is the acceleration that is gained by an object due to gravitational force. When the objects are falling down, it shows an acceleration while moving towards the Earth's surface. They are moving down towards the Earth's surface only because of the force of gravity. So this acceleration due to gravity is the acceleration that is gained by an object due to gravitational force experienced by it, which is exerted by the Earth on that object. So that is what is known as this acceleration due to gravity. And its SI unit is meter per second square. It has magnitude as well as direction. Therefore, it's going to be a scalar quantity or a vector quantity. It is a scalar quantity. Okay. You all remember we got the value of small g as 9.8 meter per second square. We had done a derivation to get the formula for small g, which is equal to gm upon r square. This r square can be replaced with d square also. It's only the vector to represent the distance between the earth and the object falling towards the earth's surface. Okay, so now I'll once again tell you. So we had derived that using Newton's second law of motion. You all remember? F is equal to ma. This is your Newton's second law of motion. Now we are talking about acceleration due to gravity. So the objects which are falling towards the earth's surface are falling towards the earth's surface only because of the force of gravity. So the acceleration shown there is what is called as acceleration due to gravity. So we'll replace the letter a by g. So my F is equal to mg now. Now in the place of F, I'll use the value that I have got while deriving that universal gravitational constant. You all remember? F is equal to g mm upon d square we took, distance. Here we can make it as r square also, no problem, is equal to mg. Small m on both sides get cancelled. So I get my g is equal to gm upon r square, or this r square can be written as d square also, because it is just talking about the distance between the earth's surface and the object falling towards the earth's surface. So it is equal to gm upon r square, or as I told you, it can be replaced by d square even, right? Now you all remember mass and weight, both are different concepts. Mass is a quantity of matter contained in an object. It remains constant, doesn't change. Weight keeps changing. Whatever weight you see here on a weighing machine doesn't occur the same when you go and check your body weight on the moon, because there is no gravity there, right? You float, so you feel light in weight, right? So mass and weight are two different quantities. Mass is the quantity of matter contained in an object, right? So let's quickly, you all remember I had shown two astronauts landing on moon and the other one on the earth's surface. His weight varies in both the cases, and those things we had done, you remember? Now I'll just do the differences between mass and weight for you. Mass is a scalar quantity and weight is a vector quantity. Mass remains constant, doesn't change, because it is a quantity of matter contained in an object. Weight changes from place to place because weight is a product of mass and gravity. So gravity changes when you go from one place to another place. Then the SI unit of mass is kilogram and the SI unit of weight is Newton. And formula to calculate mass is m is equal to w upon g, and for weight it is mg. So with this I am coming to an end of today's session. In the next session we will start with the value of small g on different portions of the earth, that is at the poles, at the equator, deep under the earth. Those things we'll discuss, and then we'll proceed with numericals. Okay, so please do learn your textbook. Whatever is given in your textbook, do read that, revise, and have a safe day. Take care. Bye.